Welcome to our today's webinar, Pt-RTD Sensor Assemblies Forward Integration to Match Your Sensing Needs. Our Pt-RTD elements are well known for their accuracy, quality, and stability. We bring these benefits closer to your application by forward integrating Pt-RTD elements with a variety of conductors and housings. What types of assemblies are available and how can they be modified or even customized? Get to know the full package of design modifications, application integration, and test performance. Our speakers today are Charlotte Klemen, our sample and ramp-up engineering lead located in Shanghai, mainly responsible for technical trainings and technical support for our customers, and Dominik Schneider, Product and Market Segment Manager for Sensor Assemblies, located in our headquarters in Kleinostheim, Germany, and leads our forward integration activities globally. And now I'm happy to hand over to my colleagues to start the webinar.
All right. Thank you, Lisa, for the introduction. And also, of course, a very warm welcome from my side. And since today it's Nicholas Day, Dominik and I are well dressed, a little bit Christmas touch to our outfit. So get yourself some chocolate and enjoy our webinar. All right, so I would like to start with the agenda and guide you through our webinar. Heraeus Next Sensors is well known as a platinum sensor manufacturer, but some of you might not know our sensor assembly capabilities. So therefore, Dominik will start with a short definition what we exactly mean by a sensor assembly. And then we'll get a little bit more technical, and I would like to introduce you to the technology and materials toolbox, the different components of a sensor assembly, how you can combine them in order to get the best performance for your application. And then Dominik will bring this to a round figure and we'll give some application examples. And then I would like to introduce you to our performance and testing capabilities in-house that we have in our manufacturing side and also in our R&D department to produce and also to evaluate our sensor assemblies. And last but not least, Dominik will give an outlook of the Next Sensors approach and our expertise as the temperature sensing specialists. And as always, and as Lisa already mentioned, we would like to get your feedback and prepared a short Q&A session. All right, Dominik, the stage is yours.
Well, thank you, Charlotte, and greetings to Shanghai. I'd like to move forward. All right, yeah. Also, warm welcome from my side. Good morning to the Europeans. Good afternoon, everybody in Asia. Thanks for joining us today on Nicholas Day. Well, Charlotte, you mentioned it. How do we define a sensor? What is a sensor assembly? I think it makes sense for the beginning of the webinar to calibrate us here in the audience, what the focus for today would be and how we understand sensors, Pt-RTDs, and sensor assemblies most of all. So I brought this slide at the very beginning to kind of show you the supply chain or the internal supply chain we have at Heraeus Next Sensors. Actually, we make a lot of our materials internally, specifically precious metals, that we then use for making our thin film Pt-RTDs, which you see on the left side. You see SMDs, you see PT elements, you see PCBs. Actually, this was the core of the previous webinars that we were holding. But today, it doesn't work, but today, the focus is more on the right side. You see different kinds of assemblies where we use the Pt-RTD as the core, as the heart of every sensor, and we forward integrate it. Sometimes very simply, we attach wires or cables, but in many cases, we go very application focused and add housing that is made for a very specific application or market. And you see a variety of different examples here on the right side. So that's the focus of our today's webinar. Then also, maybe one moment to kind of have an inspiration where these assemblies and Pt-RTDs assemblies are going and what is the drivers that we as Heraeus Next Sensors see today. Very high level, we see three market drivers that I brought into this slide. One is connectivity and digitalization. So a lot of things, a lot of equipment talk to us today, and you have to have an electronic signal, and in order to have that, you need a sensor. So there is an increasing amount of sensing needed in the markets. Secondly, we see sustainability. There, very specifically, e-mobility, where a lot of new players, a lot of new companies, a lot of new supply chains are formatting with different needs. And you also see on the third point, ease of sensor integration. A lot of companies come to us and say, look, I want to measure temperature, but I'm not an expert for Pt-RTDs. I said e-mobility is one of the big topics for us here at Next Sensors. And in there, specifically charging infrastructure, I brought an example for that that we will touch on later, and e-motor. Environmental, in most cases, wind turbines are important here for us. Health, you see below, even for the COVID situation that we're unfortunately still in, you have to you have to get the test results, and you kind of go in labs where you have to very precisely introduce temperature to get the right result, hopefully. So our sensors help doing that, and also our sensor assemblies. I mentioned appliance and consumer. I just built a new house. We have a new kitchen, and it feels like every equipment in that kitchen would like to talk to me, and there's a lot of sensing in there. The last one I haven't touched on was process industry. Obviously, many of the equipments and factories out there need specific temperature sensing. So a lot of our RTDs and assemblies go into that market as well. So this is just to give you a little bit of an idea on the drivers that we see, and yeah, applications, markets, where our assemblies and RTDs are typically going. All right, so what is impacting a design for a sensor assembly? And for us, really, internally on our side, every assembly is a new puzzle, if you will, right? So every application is a little bit different, and the construction of every sensor and the attention is a little bit different. So you have to be creative on you know, on the way to get to your target. And I brought one example that we had previously here in-house, where a customer was coming to us, a very typical question, saying, I need a sensor, I need to measure temperature. This customer was in the e-mobility space, and he wanted to fabricate a fast charging liquid cool station for public use, so outside as well. And very simple question, I just need a sensor, can you give me something? And then, well, we said, look, there are a few more layers below that. It's great that you come to us, but we have to think about which materials we use, which construction we do, to make sure that it actually does what it's supposed to do and what you want it to do, and also for the lifetime. So we typically have a lot of questions at the beginning, so hopefully that's not too annoying for you, but it's critical to understand what temperature range we typically see, how accurate the sensor needs to be, what currents and voltages are there. We have high power fast charging equipment, high voltages, so you want to make sure it doesn't burn your RTD element. And then, of course, where actually do you want to position it? How do you mount it? How is it integrated in the overall equipment? Also, size. Do you have to go very, very small because you have to go into a thin hole? Can it be bigger? Important question you have to consider at the very beginning. And then, of course, which environment do you see in the equipment? What's the environment that you can see outside? Is there vibration, high stress, pull forces, pressures, high temperature loads? All of that belongs to the operating environment. And last but not least, you don't want to build it and the performance change after day one. You want to preserve this condition. So performance over lifetime and performance stability is a very important puzzle that we typically look at as we have a new opportunity or a new sensor assembly that we can design. So that being said, I leave it at that. I come back to this topic later, but now Charlotte, you prepared a few slides to kind of explain and show us what's actually behind the puzzle. What is the toolbox that we can use internally, to create a new puzzle as we move forward.
Yes, thank you, Dominic. Now it's my turn. I would like to introduce you to the Sensor Assembly Toolbox. And here you can see one of our standard products, an EC3032, that's how we call it. It's actually an M222 sensor element. It's housed in the semi-rigid and quite flexible housing and sealed, and also attached to a PTFE cable. When we now go a step further, yes, exactly. Then we can see the different components of that EC3032, and that's also the setup of all other sensor assemblies. So a sensor assembly consists first of all of what we can see here in orange, a sensor element. Then we can see in gray a sensor tip, which could be a sensor housing and also a protection material. Then we have the connection technology, here shown in green, which is really the connection from the sensor lead wire to the cable. And then we can see in blue the conductor, and in purple the tail end. So yes, again, one step further, I would like to now build on to the image that Dominic was just using of a puzzle, because we can see all those different components as puzzle parts, which needs to be matched to each other and also needs to match to the application. And here we can see some requirements that a customer and an application could have. It can be consisting of the measuring performance of the sensor. It could refer to the temperature, to the and to the installation conditions. So let's start with the measuring performance. This consists out of the accuracy, the long-term stability, the drift behavior, and the response time of the whole sensor assembly. And the sensor element has the highest influence on this measuring performance. And that's why it's indicated here in this chart in dark orange. But not also the sensor element. In this example, it would be an M222 tolerance class B, but also the sensor tip is influencing the measuring performance, especially when it comes to the response time. There it has a decisive factor. But also to the rest parts of the measuring performance, since if the sensor tip is not suitable for the sensor element, it could harm the performance of the sensor element. Let's get to the next requirement, the temperature. We talk here about the maximum operating temperature, the minimum, and the temperature range. And actually, all different component parts of the sensor assembly need to be matched to the application's temperature. So we need to choose the right sensor element. We need to choose the right materials for the sensor tip. Also, when we talk about the connection technology, for example, soft soldering connection would not withstand really high temperatures. And depending on where the sensor assembly is installed, also the conductor in the tail end need to be adapted in terms of the temperature. Sometimes a customer might have really special requests concerning the environmental conditions. That could be that the sensor needs to be resist really high currents or voltages, or it's exposed to humidity, to oil or other chemicals. And it could also be that it needs to withstand mechanical stresses. Here's an example given of the shock and vibration resistance. And especially the sensor tip is here decisive, since the sensor tip needs to protect the sensor element. But also the other parts, like the sensor element, the connection technologies, and the conductor need to align with those environmental conditions. And last but not least, the sensor assembly needs to be installed, and therefore it's very decisive when it comes to size, to mounting methods, and also to the electrical installation. Talking about the size, the main influence has the sensor element and the sensor tip. And sometimes the customer wants to have an easy installation of the sensor assembly. For example, he wants to simply screw it in, plug it in, or glue it in, or whatsoever. Then we need to adapt the sensor tip in terms of that mounting requirements. And the conductor and the tail end are decisive for the electrical installation. The conductor, for example, when it comes to the length of the conductor, and for the tail end, the plug could be really customer specific. All right, so this was a really general sum up. And on the next slide, I would now like to introduce you to what kind of solutions Heraeus sensors could offer. So here you can see kind of the same setup. In the center, we have the EC3032, and it's surrounded by those different components: the sensor element, the housing, the connection technology, the connector, and the tail end. So let's get a step further. So here we can see now our approach sensor portfolio. Next Sensors is one of the leading manufacturers of platinum temperature sensors. So we can use actually our whole portfolio to build up a sensor assembly. Here the examples of a wired, a PCB, and an SMD parts are given. And we can, of course, adapt the sensor in terms of resistance, nominal resistance, in terms of the temperature range, in terms of size, and so on, accuracy, whatsoever. Okay, next slide, or next part of the slide. Okay, so the next component would be then the sensor tip. And you can distinguish the sensor tip into the housing and the protection material. So let's first have a look at the housing. Here is just a selection given what or how how could look like. We already talked about the first example here. The polymer tip is semi-rigid and encapsulated housing, but it's not, or it's very suitable for applications with vibrations, for example. But when you want to work in an application with higher temperatures, then maybe the steel sleeve could be a solution. When customer is asking for an easy installation of the sensor, maybe he wants to screw it in, then a screw, a hack screw, or a ring terminal could be a good solution for the customer. And the last example to given, the polyamide and the overmolded sensor housing are suitable for surface measurements. And sometimes you will need a protection material inside that housing to fix the sensor and also to ensure a good response time. Here again, just some examples given: the ceramic, the silicon, and an epoxy. And the sensor tip really needs to align to the sensor element, because otherwise it could maybe influence the performance of the sensor element. Okay, next part. Here you can see a selection of the conductor. Of course, our sensor is a passive component, therefore it needs to be energized, and therefore we're going to need a cable or a lead extension. So the conductor could vary in terms of material, in terms of the diameter, or for example of the length. So I don't want to go through those all materials, just so let you know that of course we can react to customer requests and can adapt the selection here. And we can also manufacture a 2, 3, and 4 wire connection. Okay, next one. And you will always find a recommendation of the connection technologies on the data sheet of our sensor elements. And the recommendation is there because it needs to be matched to the material of the lead wires of the sensor element, and the connection technology also needs to be matched to the application temperature. Okay, and now let's come to the last component, the tail end. This could be a strip, a semi-strip, or all different customer specific connector types. All right, so this is a summary of the toolbox. Important is we can see that as a puzzle. All those different components need to be matched to each other, but also to the application. All right, Dominic, it's your turn.
All right, thank you, Charlotte. Well, we had now a good insight into the toolbox, and I would like to recall and go back to the opportunity and this project that we had around the sensor and the fast charging cooled station. You see on the left side, I just briefly put in bullet points what the customer need was at the time. We understood that the sensor should have be positioned or should be positioned in the hydraulic cooling system of the equipment. Fast response was important to save the equipment from any damages, and last but not least, a very important go-to place was that we have an easy integration and an easy repositioning of that sensor in the equipment. In other words, the customer didn't really know where to put it at the beginning, so they wanted to be flexible on where to put the sensor in the end. So I wanted to take you on a journey here and kind of let you know how we put the puzzle together and how that process was and is on our side here at Next Sensors. So you see here, after very much describing that customer need and understanding that, questions from our side, next step is the RTD concept. Again, the sensor is the heart, the core of the whole device, and the RTD is very important here, and the RTD selection. So we decided for an M310 here, a very small one, because it needed to fit in small holes. We decided for laser welding to connect the wires in a sustainable way to the element. And we decided for silver copper strands and for a PTFE installation to make sure that we have good electrical performance and that the insulation also will withstand higher temperatures. Next point, that was something that Charlotte was also explaining. We looked into our toolbox of housings. It's like gloves for a mechanic, right? You don't want to put too big of a glove on your hand, so you still have the touch and feel and the tactile feedback, but you don't want to go too thin, otherwise you might hurt yourself or you have debris on your fingers. So that's always the balance. Don't put too much housing around it, so you have a good response time and a good performance of the sensor, but you want to put enough around it so it sustains over the lifetime of the product, and yeah, it doesn't fail along. So in this case, we decided to move forward with a brass housing. It will sustain in liquids very well, and it also has a retention feature because there needed to be a secondary polymer housing around it, so it actually fits into a customer coupling, which you see on the next bracket, which we defined as fit for function. So left side is housing and how we protect the sensor and make sure that it works in the performance that is needed. And fit for function really is, okay, how can we incorporate that into the standard system of our customer? And that T has a coupling on each end that can be very flexibly positioned in the fast cooling equipment. We started with polymers of that T. You now see the metal, just to make sure that it sustains in the higher temperatures. And what you can do, you can pull out that sensor and you can put it on the other sides. You can put it on any coupling of that hydraulic cooling system in the charging station, which makes it very flexible. If you look to the left, easy integration, repositioning, this is where we said, okay, these are the features that actually allow to do that. And I know, Charlotte, you will talk about performance and testing a little bit further in this webinar, but I just wanted to highlight that we always look individually at every single application, every single sensor. And then we try to figure out what tests are comparable to the real life. And then we do these tests. Like for X-ray, for example, we wanted to make sure that the sensor is very much at the tip and in the fluid. Response time is the background. pressure test, of course, the water, the liquid cool, is under pressure. You don't want to have the sensor popping out of that coupling. So we made a pressure test, and same direction is a tensile test. So we pulled on it to make sure that it actually withstands any kind of pull force that might occur during assembly of the equipment or later on in the process time. And then, of course, we have our application team globally, and in the meantime, we would develop the product here in Germany, but we also have good understanding of automation, and we also have a very cost-efficient facility in Malaysia, in Johor, where we would scale to volume. We would also do an automotive qualification, which we would have done here in this case as well, and different kinds of labelings that are necessary for this application. So I wanted to take you on that journey, how we came from the customer need and the idea to the final solution, actually to a scale into volume. Now, this is the summary slide, or the result of that whole exercise. So what's the performance of that combined puzzle now of that sensor? You see on the top left temperature, so you can put it into the Antarctica, you can put it into the Sahara, you can drive the equipment at the extremes with the processes and the materials that we have chosen. So -50 to +200 degrees. In extreme conditions, it will work. We used very small elements to make sure that we can protect the sensor, but it would also fit into that coupling. Mounting method, I explained that you can very flexibly position and reposition that sensor among the entire cooling system of the charging equipment. Currents and voltages, honestly, this is not part of the charging gun, so voltages are a little bit further away, but the customer said, look, it's still part of our high voltage equipment. Let's make sure it would sustain in case there is any voltage there. So we have a high voltage resistance and a high electrical performance for this construction as well. Fit for environment, hermetic seal, so there is no leakage. Optimized heat transfer, which means that we use a brass housing that is very much made for this kind of application. And you see, I put a little red arrow in the middle. You see where the PT sensor is actually located. So response time, you might remember that need. We put it right into the liquid, so I have a good response time. Performance, stability, everything we have chosen on materials and processes is made to survive the lifetime, or even more than the lifetime of the product or the equipment in this case. So this is how the puzzle comes together with the toolbox that Charlotte explained. And now I have one more example where you just see the puzzle now. I don't take you on the journey. I think you could follow on the flow sensor. This is the EC3032. Charlotte, you talked about this one. We wrote here maximum protection in the minimum package, and the idea was for HVAC applications. In HVAC applications, a lot of times you have the challenge that you have condensation, moisture potentially creeping into the sensor area and harming the performance over time. So the construction that you see here in the middle looks very simple. It's a polymer flexible tip, but it's highly dense. It has a low thermal mass, so very good response time. And we approved it as IP67 and IP68 compliant. So it's really performs really well if you have a wet environment, if there's moisture, if there's dust, if there's vibration. This product performs very, very well. We can even make this one size smaller. So if you have to go very small, you can do that. And you're very, very flexible on how to mount that sensor in any kind of HVAC equipment. So I just wanted to give that to you. You kind of can build a bridge between the starting of it and the application in a specific equipment or application. Good. So this was it from my side for now. Charlotte, I would again hand over to you to talk about testing.
Exactly. Yes, I would like to introduce you to our test capabilities that we have in-house in our manufacturing side, but also in our R&D department, in order to be able to produce the sensor assemblies but also to evaluate the performance and, of course, to improve the performance of the sensor assemblies. So again, let me use the image of a puzzle. Here we have three different puzzle parts: the measuring performance, the environmental conditions, and the installation conditions. Let's start with the measuring performance. Here, mainly, it's depending on the sensor element, and it's influenced by the sensor tip. When we come to the environmental conditions, actually each application has different requirements and environmental conditions, and especially the sensor tip has to align with these conditions. And when we install the sensor assembly, we have the installation conditions, and we need the test capabilities to evaluate the different performance data and to provide visual control of sensor assembly, design, and process step. So let me now jump into each one of those puzzle parts. All right, so here you can see the test capabilities of the measuring performance. Belonging to the measuring performance, of course, is the accuracy, the long-term stability, and the drift behavior of the sensor assembly. And on the bottom, you can see three test setup that align kind of to those measuring performance here. A very standard test setup is the temperature and cycling test. So for example, the sensor assembly would be exposed to a temperature cycling from -50 to 150 degrees Celsius for 1,000 times. And then we have the temperature storage test. This test is also specified in the DIN norm. A very standard test setup would be to expose the sensor to its maximum operating temperature for 1,000 hours. And sometimes maybe not the high temperature region might be decisive, but the low temperature region. That's why we also have in our validation analyze center a low temperature measurement, for example, to measure the cryo temperature range up to -196 degrees Celsius. You will also find the response time and the self-heating as characteristics on our data sheet. And actually both are measured in the same equipment that you can see on the top right for the self-heating. So let's talk about the response time. That's the time a sensor needs to detect the temperature. It's actually very decisive for a sensor assembly. And the sensor needs to be energized, therefore it a slight self-heating could occur. So with this test setup, we could determine both. All right, next slide, please. Okay, so here you can see that we also stress our sensors assemblies to very specific customer-specific requirements. So for example, the customer needs the sensor to withstand high voltages or high currents. And then we can have here an insulation resistance test and a dielectric strength test. You will also find on our data sheets an indication about the shock and vibration resistance. The test setup is shown on the top right. It kind of looks like a robot from Star Wars. And then we also carried out an oil leak test. So we exposed, in that example, the EC3032 that we already talked about into heated oil and energized it. And so no effect on the sensor's performance. And the last very crucial test setup here is the heat humidity test. So we don't only expose the sensor to a temperature, but also to humidity. And this test could also be called an 85-85 test. So we expose, for example, the sensor for 500 hours at 85 degrees Celsius and 85% relative humidity. All right, next slide. Yes, this is our last slide concerning the test capabilities in-house. So all the sensors need to be installed, and therefore we have some test equipment to ensure a good installation condition of our sensors assemblies. So, for example, the tensile tester, we can measure the strength, and Dominic also referred to it. We can measure the strength between the lead wires and the cable. For example, for the EC3032, we specify a tensile strength of approximately 100 Newton. If we now install an SMD part on a PCB into that assembly, we could have a shear test to evaluate the soft soldering connection of the SMD part to the PCB board. And we also carry out different visualization tests in order to evaluate the construction of the whole sensor assembly. For example, here you can see an X-ray result or a light microscopy. Okay, so this was a short summary of what kind of test capabilities we have in-house. And I would like to make one more comment. What's really important, even if you install like the best performing sensor element, let's say a tolerance class A element, it might be influenced by the housing and by the installation itself. And that's why you have us as experts for sensor assemblies. And now the word goes on to Dominic.
Thank you, Charlotte, for that comprehensive summary. I know there's a lot of tests in-house here today, and it's very hard to structure them. But thanks for that good summary and the good condensed way to present it. Well, we are getting to the end of the presentation material. There's 2 more slides. This is almost the last one here. We just wanted to bring that to kind of give you an understanding how our portfolio looks like and how we approach it. So we are not in we are not in sensor assemblies just for a few months. Actually, we do this for many years, 10, 20 years at least on our side. So we have legacy products and we have an existing running production that we do today. So a lot of puzzles are already completed on our side, is the message. And then we strategically look to adding new puzzles where we also say, okay, you can add different you can add or change different pieces of the puzzle. You can change the RTD, you can change the wire, you can change the size. This is what you see in the middle as portfolio extension, and I put in puzzle adaptable. You see a range of products that we have done or are on the radar. Where you see the screw head, you see PCB type assembly, ring terminals in different sizes. Yeah, we are approaching a mini steel tip where we go very small to have a very flexible sensor made for yeah, very challenging applications and very challenging environments. And then of course I took you on that journey around customer projects and entirely new puzzles where we get to the table and think, okay, how can we do that? One of them was the flow sensor. I put the image here again to find orientation in this graph here, but there are many more, as you can see here on the right side. Yeah, where we are always open to talk about how we can design a sensor that it works for your specific application. And last but not least, to your point, Charlotte, to also test it in the environment that you have in your equipment or in your application. Want to make sure it works and it does the job that it's intended to do. So that's the overview on that, and this is the last slide of the slide deck. 3 topics as you think of next sensors. One is technology and quality. So we have millions of RTDs already in the field. Yeah, I hope we could show you that our assemblies are engineered to custom applications. That's a very critical point for us. Also in our mindset. Yeah, we are an IATF certified company, and we always strive also to allow certifications. We have IP67, IP68, AEC-Q, so we can bring it to the quality level and to the standard that you need also in your business. And then last but not least, yeah, performance and testing is a big topic for sure. Scalability, I think what we can do, we can work, you know, on samples, making a few prototypes, make a few hundred pieces. But as soon as you say, look, I need somebody who's there for me to also scale it to a higher volume, we can do this with automations, but we can also do this on our cost-efficient side in Malaysia, as I explained earlier. We have global application labs. Charlotte, that's why you're in Shanghai today, so to support the activities there. So we have a good footprint here in terms of scalability from small to big. And in terms of sustainability, we've been around for quite a while, over 100 years, far over 100 years, pioneer in temperature sensing. We look for sustainable supply chains, sustainability of the supply, but also sustainability in general from environmental perspectives. And of course, we will be there also in the future. So our focus is really on long-term partnerships. Yes, so this is the summary from our side.
Yeah, so thanks for joining the webinar today. As Charlotte said, sorry for the technical issues. We will work on that. Have a nice day and thanks.
Yeah, thank you for joining the webinar today and happy holidays to everybody.
Yes, thank you and bye-bye.
Bye-bye.
Bye.